Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover for topic 8, okay, which we will continue from our last lecture. So this is subtopic 8.4.1, which is the equation of lines in space from topic 8, which is the topic of vector. Okay, so we already learned about vector. So today we want to look at how to create equation of a straight line by using vector. Okay, so firstly we have to know there are three types of equation that we can use to represent a vector. Okay, the first one is the vector equation. Okay, and then which is the parametric equation, and then the third one is called as the Cartesian equation. Okay, so all of these three equation, okay, originally starts from the vector equation. So let's look at how can we form a vector equation from a given points and two vectors. Okay, so we read from here, we can see that a line is a space in a straight line which continues indefinitely in both direction and contains a continuous infinite set of points. Okay, which means this is the line of a vector. Okay, this is the equation of the line that we will create. Okay, this is the equation of the line. Okay, this line actually depends on a point of A, which is the fixed point. Okay, A is not movable, it's a fixed point, and also depends on the equation for a vector A and also for a vector R from here. Okay, okay. Okay, this point of R represented with the capital letter of R is any movable point. Okay, it means any point that lies on the straight line. Okay, so it only be represented by the X, Y, and Z because the point is movable. So it can be any value can represent the value for the coordinate of X, Y, and Z. Okay. Meanwhile, the A is a fixed point. Okay, remember that A is a fixed point. Okay, later we will have the value for the X, Y, and Z component for the point A. Okay, alright. So suppose that R, so you can read right here. Suppose that R, X, Y, Z is a point which move on a line containing a fixed point A. Okay, so A is a fixed point. So R is a movable point. Then a vector V, which is the from vector V is equal to point A to point R. Okay, I change the color of this. Okay, is the direction vector of the line. It is clear that a line consists precisely of those points for which the vector AR is parallel to V. Okay, alright. So V is the vector from point A to point R. Okay, but R is unknown. Okay, point R is unknown. So we know that vector AR is equal to OR and then minus with OA. Okay, so since vector AR is also equal to V, so this OR minus OA will equal to V. Okay, so since vector V is a vector, but it is only a direction vector. We didn't know what is the length, what is the magnitude of the vector V, but we only know the direction only. Okay, so it can be said that OR minus OA is equal to TV. Okay, T is a scalar. Okay, a scalar that later will can be used to represent the length of a vector V. Okay, it's a scalar that we multiply with the vector. Okay, so we can rearrange this equation. So we can say OR is equal to OA plus T V. Okay, then vector OR is equal to R equal to then vector OA is equal to A plus TV. Okay, so now we have the equation of a straight line. There is R equal to A plus TV. Okay, so this is what we call as a vector equation. Okay, a vector equation form for a straight line. Okay, all right. So what we have to recognize from the R equal to A plus TV. Okay, R represent the point from the origin to the point R. Okay, since point R is unknowable. Okay, we didn't know where is the point R, so we can say that vector for R is only xi plus yj plus zk. Okay, to represent the vector R, since point R is unknown and it starts from the origin. Okay, and then equal to vector A. Okay, then vector A. Vector A is from the origin to a fixed point of A. Okay, a fixed point of A. So we know the value for fixed point of A. Okay, so but for now I will only use x1 I plus y1 j plus z1 k to represent the A, and then plus with t is a scalar, and then v is the vector A to vector R. Okay, okay, v is the direction vector, okay, also known as a direction vector. Okay, I use it as AI plus BJ plus ZK. Okay, it is important for you to know which vector represent which part, because in this one equation of line, okay, as we can see, we have three sets of vector equation. Okay, as the one for the vector R, one is for a vector A, and another one is for vector V. Okay, but however, these three vectors, when put in this one equation, is the R equal to A plus TV right here. Okay, it's only represent one single line. Okay, it so it only represent a line. Okay, one single line. All right. Okay, next we continue from what we already have right here. The xi plus yj plus zk equal to x1i plus y1j plus z1k plus t a scalar ai plus bj plus zk. Okay, which all of these components come from the equation of a straight line r equal to a plus tv. Okay, as we can see, we can make a comparison. Okay, we can compare the I and also the I, but don't forget the T from the scalar, which we can gather all the I and X. You can say the X is equal to X1I plus A. Sorry, we don't have to put the I, X1 plus A T. Okay, that's for the X. And then for the Y and B. Okay, then Y equal to Y1 plus BT, and also we have Z equal to Z1 plus CT, or sorry, why do I put Z right here? Actually, C, okay, CK, not ZK. Alright. Okay, so now we have three separate equations. Okay, these three separate equation is what we call as a parametric equation. Parametric equation. Alright. Okay, so now we already know the second types of equation for line in space, which is the parametric equation. The first one is the vector equation. Okay, then next is Then next is the, okay, we can say that all of these equation have the t and t. So we can say t, we can rearrange it as t equal to x minus x1 over a. Okay, and then t also equal to y minus y1 over b, and also t is equal to z minus z1 over c. Okay, there. So since all of the t come from the same value of a scalar, so we have x minus x1 over a equal to y minus y1 over b equal to z minus z1 over c. Okay, then this is our third type of equation, which is the Cartesian equation. Alright, so we already know the three types of equations to represent equation of line in space. Which one is the first one is the vector. That is r equal to a plus tv. And then the second one is the parametric equation right here. And then the third one is the Cartesian equation. Okay, now let's look at example 8.28. Okay. Okay, the question says find the vector equation, the parametric equation, and Cartesian equation. So all three types of equation that I already shown to you of the line through point. Okay, so this is the point, which is the fixed point at 1, -2, and 3. Okay, okay, and in the direction, okay, direction of 4i plus 5j minus 6k. Okay, so to do this, okay, to find the vector parametric equation, we must start with the equation of a vector, which is the r equal to a plus tv. Okay, so r equal to a plus tv. Okay, so we have to identify which one, the r, okay, which one is the a, and which one is the v. Okay, so a represents the vector from the origin to the fixed point. Okay, r, we keep it as a r. Okay, then a is the direction vector. Okay, it's the direction vector from the fixed point to the origin. So that is the I minus 2j plus 3k. Okay, that is for to represent the vector A, and plus t is the unknown scalar. Okay, and then v is the direction of the vector. Okay, direction vector of 4i plus 5j minus 6k. Alright, so v is actually the direction vector from any point from the fixed point. Okay, from any point to the fixed point. Okay, so 4i plus 5j minus 6k. So this is the vector equation. Okay, and then we have to find the parametrics equation. So to find the parametrics, firstly we have to expand the vector r. Okay, vector r is the xi plus yj plus zk. So equal to I minus 2j plus 3k plus t and the rest. Okay, so we have to compare the I component, and also the I component. So x equal to 1 plus 4t y equal to -2 plus 5t, and then z equal to 3 minus 6t. So this is the parametric equation. Alright. Okay, and then from parametric equation, we have to form the Cartesian equation. Okay, rearrange all of the three equations from parametrics. So we have t equal to x minus 1 over 4, then t equal to y plus 2 over 5, and then t equal to z minus 3 over with -6. Okay, so our parametric equation is x minus 1 over 4 equal to y plus 2 over 5 plus z minus 3 over, sorry, not plus, equal to z minus 3 over -6. Okay, so that is the answer for the equation. For the question example 8.23. Okay, for those who didn't understand yet what does the equation means, okay, the equations actually wants you to find the equation vector equation from a point 1, -2 and 3, okay, that has a direction, a vector in the direction of 4i plus 5j minus 6k. Alright, okay, so this is what actually happened right here. Okay, v is the direction vector from the fixed point of 1, -2 and 3. Okay, so v, the direction vector, so this is the direction in the direction of 4i plus 5j minus 6k. Okay, we can interpret these two kind of things, these two things, which is the point and the equation vector, into three types of equation, which is the vector equation, parametric equation, and also the Cartesian equation. Okay, we proceed with next example, example 8.29. Okay. Okay, so from this example, a line has Cartesian equation of x minus 1 over 3. Okay, yeah, we just rewrite it down first. Equal to y minus 2 over 4, z minus 3 over 5. Okay, find a vector equation for a parallel line passing through the point with position vector. Okay, so this is our first equation. Okay, so the question says that we already have a line with this Cartesian equation. Okay, so this Cartesian equation represents this line. Okay, so we have to find a vector equation for another line that is parallel to our Cartesian equation. Okay, means it must be parallel, and this new line is passing through the point with position vector of, okay, point with a position vector means the point coming from the origin with a position vector of 5i minus 2j minus 4k. Alright, so straight away, since it is a position vector, so we know the coordinate for point P is actually 5, -2 and -4. Okay, so this is our fixed line, our fixed point. So firstly, we have to know what is the direction of the vector, okay? Since it is must be in parallel, so we take this Cartesian equation, okay? change it back into vector equation in order to find its direction vector. Okay, direction for this vector. Okay, so we know that x minus 1 over 3 is equal to t, and y minus 2 over 4 also equal to t, and z minus 3 over 5 also equal to t. Okay, then we have x equal to 1 plus 3t, then y equal to 2 plus 4t. Okay, and then we have z equal to 3 plus 5t. Okay, so now we have changed the Cartesian equation into parametrics, and then the parametrics we can change it back into vector equation. So we have together x, y, and z becomes the vector for r. That is the xi plus yj plus zk equal to, then the 1, 2, and 3 is the I plus 2j plus 3k, and then plus with t. Okay, and we have 3i plus 4k plus 5j. Okay, so that is our vector equation in the form of r equal to a plus t v. Okay, so right here, so 3i plus 4k plus 5j represents the direction vector for this one lah, 3i plus 4k plus 5j. So since it is in parallel, so this the blue vector must also will be 3i plus 4k plus 5j. Okay, since they are in the same direction. Okay, so next we have to create another equations to represent this new line. Okay, to represent this new line that has a fixed point at 5, -2, and -4. So another r equal to a plus tv. Okay, r is unknown. Okay, then our a is the position vector for our fixed point, which is the 5i minus 2j minus 4k plus with t and the direction vector coming out from that fixed point. That is the 3i plus 4k plus 5j. Alright, so that is the equation of the line that we are looking for. Okay. And the next question wants us find the coordinate of the point on this line where y is equal to 0. Okay. Means we already have the equation vector. Right now the point P is at 5, -2, and -4. Okay. So along this line, we have to find the coordinate where the y is equal to 0. Means it could be right here or anywhere, but must be along the line where the x, the y is 0, and the z. Okay, we have to find the coordinate for x and the coordinate for z. Okay, so in order to find that, we have to convert this parametrics equation. We have to convert this vector equation into parametrics. Okay, so we have x I plus y j plus z k okay. So this is the x and this is the z that we are looking for. Okay, so we have we change it into parametric form first. So x equal to 5 plus 3t, and then y equal to negative 2 plus 4t, and then we have z equal to negative 4 plus 5t. Okay, so since we already know the value for y, that the point is when y is equal to 0, so we change y is 0, negative 2 plus 4t, and then we have t equal to 1 over 2. So we can use the value of t by substitute it into the equation of x, 5 plus 3, 1 over 2. Now we have x is 13 over 2, and then z, negative 4 plus 5, 1 over 2, and then we have z equal to negative 3 over 2. So now we have the value of x and the value of z when y is equal to 0. So means the coordinate is at 13 over 2, y is 0, okay, and the coordinate for z is negative 3 over 2. Okay, so that is the answer. Okay, we proceed to next example. Okay, example 8.30. Okay, find parametric equation for the line L passing through points P1 and P2. Okay, so means we have a line from P1 that is at 2, 4, negative 1. And then we have another line at P2, 5, 0, and 7. Okay, so parametric equation means firstly we have to create the vector equation that is R equal to A plus TB. Okay, so what's important right here to create the vector equation? Firstly, you have to assign a fixed point along the line. Okay, so right here we have 2 points in a single line, which is the point 1 and point P2. Okay, so it's up to you whether you want to assign P1 or P2 as your fixed point. Okay, so for this one, we just use point P1 as my fixed point. So my vector for A will be the 2i plus 4j and then minus k. Okay, because I use P1 as my fixed point. So later I want you to use P2 as your fixed point and get your own equation. Okay, and then try to solve equation B by using your own line equation. Okay, so I continue with the equation A and then plus T, and then my vector V is just the vector from P1 to point P2. Okay, V is from P1 to point P2, so I have 5 minus 2 is 3i, then minus 4j, and then plus 8k. All right, so I already have my vector equation. So change it into parametric equation. So I have to open this one. Change the vector r into x, y, I, j, k component. xi plus yj zk, 2i plus 4j minus k plus t, 4j plus 8k. Okay, so right here I will have it as x equal to 2 plus 3t, and then y equal to 4 minus 4t, and then z equal to negative 1 plus 8t. Okay, so this is the answer for question A. Okay, then for question B, question asks where does the line intersect the XY plane? Okay, XY plane. Okay, so right here I draw the XYZ plane. So this is the X, this is the Y, and this is the Z. Okay, so the question says about the XY plane means the XY plane. So this is the X and Y plane. Okay, it's like a paper on the axis of X and Y. So means the X and Y plane will have a Z coordinate at 0. Okay, Z equal to 0 when we say we are talking about X and Y plane. So means we have to substitute Z equal to 0, -1 plus 8t. So we have our value for t is equal to 1 over 8. Okay, so by using this value of t, we can determine the coordinate for x. So x equal to 2 plus 3, 1 over 8. So we have x equal to 19 over 8. And then y is 4 minus 4, 1 over 8. So coordinate for y is 7 over 2. Okay, so then where does the line intersect the xy plane? The line intersect at coordinate of 19 over 8, 7 over 2, and z is at 0. So that is the solution for example 8.3.